an equation of the form the thing which I am writing is very important, students, so please observe this. X power n into nth derivative of y with respect to x plus p1 into not p1 here, I'm taking simply x power n minus 1 into x power n minus 1 into n minus 1th derivative of y with respect to x, okay, plus and so on, plus x square into d square y by dx square. What is the previous term of x square into d square y by dx square? It is x cube into, okay, I am writing that, x cube into d cube y by dx cube plus x square into d square y by dx square plus x into dy by dx plus y is equals to q of x. Right hand side will be q of x. Okay, here I am taking as a like this. The coefficient of y naught is p naught, and coefficient of this is p1, and this is p2, and this is p3, and this is pn minus 1, and the coefficient of the first term may be pn also. There may be a chance pn, where p0, p1, p2 and so on pn are constants. What about p0, p1, p2 and so on pn are constants? That is important. Okay, that is important. So p0 into y, where p0, p1 and so on pn are constants. Okay, an equation of this form is called as a homogeneous linear differential equation, or Euler-Cauchy's linear differential equation. Euler-Cauchy's linear differential equations of order n. What are the coefficients? With variable coefficients? Please make a note. This is important. Variable coefficients. Till now, we learnt the concepts of how to find the solutions of second and higher order linear differential equation with constant coefficients. But here, our next concept is second and higher order linear differential equation with variable coefficients. What are the variables? If you observe here clearly, it looks like what is a differential term? What is a constant? Is p0 is constant. Very good. Dy by dx coefficient is p1 is constant into x. What is the second? From the last I am writing p2 into x square, p3 into x cube, p4 into x power 4, pn minus 1 into x power n minus 1, pn into x power n. All these are in functions of x. But what about p0, p1, p2 and so on pn are where constants? p0, p1, p2 and so on pn minus 1 comma pn are constants. Sir, we discussed in our previous case also same p1, p2, p0, p1, p2, p2 and so on pn are constants, but here also constant. How can we say that are in functions of x variables? No, these p1, p2 and so on pn are not in functions of x variables. But other than that, we are having x power n minus 1, x power n minus 2 and so on x power 3, x power 2, x power 1 like that. Please make a note, one more important point here. It is check in each and every term, what is the derivative exists in the first term? Nth derivative. What is the power of x? Is also n. What is the second term derivative exist? N minus 1th derivative. So x power is also same n minus 1. So if we take a term contains a fifth derivative, then what is the power of x in the coefficient? Power 5. It should be like that. Okay. Now I'm going to rewrite the equation, given our equation like this. Differential operator form of the given DE. Differential operator form is, I'm writing P n into x power n into capital D power n plus P n minus 1 into x power n minus 1 into D power n minus 1 plus and so on, plus P3 into x cube into D cube plus I'm writing in the next term P2 into x square D square plus P1 into x into D plus P naught of y is equals to q of x. Q of x. Take it as equation number 1 or equation number 2. No problem. Anything. Equation 1. Now, what we have to do is, the next step is important. I'm just going with the procedure. Later, I'll discuss why we have to substitute like that only. That we'll discuss later. Okay. So here we have to go for substitution. Put e power, sorry, x equals to e power z. That implies what is z can be written as, for the reverse case, log x to the base e. Log x to the base e. Okay. And if whenever we are substituting this, then immediately we have to substitute, and also we have to substitute x into d is equals to, which I am writing with the red color is important. X into d equals to theta. X square into d square is equals to theta into theta minus 1. X cube into d cube is, so what is x cube into d cube is? Here, same manner, reduce one more value. Theta into theta minus 1 into theta minus 2. Okay. We have to go and so on like this. Substitute all these values in equation number 1. By substituting all these in equation 1, then it reduces to how it's going to become is, it's going to become as f of theta of y is equals to q of z. This is our equation number 2. Here the important point is, what is capital D? What is capital D? You know it already. D by dx. Okay. And theta is equals to, this is d by dz. We'll discuss later how you are going to substitute these other things. Okay. So from here onwards, we need to find the general solution of equation number 2. What is the general solution of equation number 2? Y equals to yc plus yp. Okay. Then equation 2 is a linear DE with the constant coefficients. Linear DE with the constant coefficients. Sir, how it will convert, that we'll see in problems. With constant coefficients. You know how to find the solution of a linear differential equation with constant coefficients. Use that procedure and find the solution. Then After completion of the total solution of equation number 2, then replace z with which one we have to replace log x to the base e. Then we'll get the general solution of the given differential equation number 1. What is equation number 1 is linear differential equation with variable coefficients. We cannot find the solution for that. Because of that reason, we are going with this substitution x equals to e power z and z is equals to log x to the base e. And also these are the substitutions: x into d equals to theta, x square d square equals to theta and theta minus 1 and so on. Then equation 1 reduces to a linear differential equation with the constant coefficients. Then we know till now from the starting of the second unit, what we discussed, we learned only how to find the solutions of linear differential equation with constant coefficients. Using that procedures, we have to find the solution and then replace z with e power x. Sorry, z with log x. This is the procedure, and we'll continue problems later. Then we get general solution of given DE. Okay, this is the concept. What is the given differential equation? Nth order linear differential equation with the variable coefficients. And for that linear differential equations with the variable coefficients, converting it into a linear differential equation with the constant coefficients. After converting like this, then we have to find the solution of equation number 2. We have to solve this equation number 2. Then we'll get a solution of y in terms of z variables, and then replace z is equals to log x or e power z equals to x. These two things, whatever it may be required, depends on our convenience. Then we get the general solution of given differential equation. This is the concept. How we are getting x into d equals to theta, x into d, x square d square equals to theta into theta minus 1, like that. Okay, I'm explaining as a rough or as a note. Okay, so this is not that much of important. Who wants to know why we should have to substitute like this only? For them, this is the answer. Here, what we are substituting, x equals to e power z. That implies what we'll get, z is equals to log x. Okay. Now, I'm doing differentiation of this. What we'll get? dz by dx equals to 1 by x. dz by dx is equals to 1 by x. This is the thing. Now, here, I'm going to take what is the general form of y? Y will be in functions of which variable? X variables. But x is in terms of which variables? What we considered in terms of z. But x is in terms of z. So now, if I want to find, x is in terms of z, but in the same manner, here what we have taken, z is also in terms of x. So instead of this, but x is already in terms of, okay, z is in terms of x. Y is in terms of x directly, but indirectly, y is in terms of z, that is in terms of x. Now, we, in your LAC subject, functions of several variables, you learned there in the chain rule, y by dx. If we want to travel from y to x, how to travel from y to x? Dy by dz into dz by dx. You learned this. But what is dz by dx is nothing but 1 by x. So I can write it as 1 by x into dy by dz. Now, what we considered, consider what is d by dx is nothing but capital D. And consider d by dz is equals to theta. d by dz is equals to theta. Now, in the same manner, what is the left hand side is going to become as capital D y is equals to 1 by x into, what is the right hand side part? Theta of y. Yes or no? Y. Now, here y, okay, same both. Then we can write d is equals to or 1 by x into theta. With this, what we can write, that implies, can I bring x to left hand side? It becomes x into d is equals to theta. So with this explanation, similar, I am writing, if we do in the same manner, we are going to get, similarly, we are going to get x square d square is theta into theta minus 1, but x cube d cube is equals to theta into theta minus 1 into theta minus 2, like this. Sorry, theta minus 1 into theta minus 2, like this we are going to get. So, and so on, we can continue the same process. We can continue the same process for all the things. Okay. So this is the explanation for how we are going to get x into d is equals to theta. Now going to start our problems. The given differential equation is x square into d square by dx square minus x into d by dx plus y is equals to log x. And writing it is in the form of a differential operator form. What is the given differential equation number 1 is, if you observe clearly, what is the power of d? 1. What is the power of x? 1. It is also the coefficient of the same term. That means in the term, the differential term. In this term, first term, we are having second order derivative. But what is the power of x is also 2. So what we can conclude with this equation 1 is a Euler-Cauchy's linear DE. Euler-Cauchy's linear differential equation. Okay, this is the thing. So because of this is a Euler-Cauchy's linear differential equation, what is the general solution? In general, up to now, we have taken y equals to yc plus yp, but this is not the solution. That is not the general solution here. What is this process we discussed? We have to convert it into, what is the equation number 1? And equation 1 is a linear DE with variable coefficients. A linear differential equation with the variable coefficients. This is important. With the variable coefficients. This one we have to convert to linear DE with the constant coefficients. Like that we have to convert. For converting that, we have to substitute here. What is the substitution? Anybody can say? Put or substitute. What is x? Equals to e power z. That implies z equals to log x. Z equals to log x. Now, and what are the few more things we discussed? What is the procedure? Same steps we have to remember. What is the procedure? X into d is equals to theta. X square d square is equals to theta into theta minus 1. This thing we need to substitute, but I am going to simplify here only. So what is the theta into theta minus 1 becomes as theta square minus theta, where what is capital D? D by dx. These steps in every problem you must we need to write, and theta is equals to d by dz. This is important. So now substitute in equation number 1. Substitute all this in equation 1. If we substitute, what is equation number 1? X square d square. What is x square d square? Is theta square minus theta. Theta square minus theta. This is xt, and this is a x square d square is theta square minus theta. So going to substitute it, that implies theta square minus theta is the first term minus xd. Xd is nothing but theta plus 1 of y is equals to. What is the right hand side? What is the right hand side? Log x. What is the log x? Is nothing but here it is. What is the log x? Here it is. Z. 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 So taking this as equation, okay, before going to take the equation number 2, I'll do simplification. Then tell me what we'll get here. It is theta square minus 2 theta plus 1 of y is equals to z. Taking this as equation number 2. What is this equation 2? Is a linear DE with constant coefficients. With constant coefficients. Now, what is the given problem? Linear DE with variable coefficients. That linear DE with variable coefficients we converted to linear differential equation with the constant coefficients. After we converted this, what is its general solution? Then general solution of equation 2 is what is the general solution of equation number 2? Y equals to yc plus yp. But here, what is the right hand side part? What is equation number 2 is in the form of, that is, it is in the form of f of theta of y is equals to q of z form. Q of z form. So yc and yp will be in functions of z variables. Now you people can understand why I explained one problem in terms of t variables. Okay, so now how to find yc? Finding yc. For which equation we have to find yc? Equation number 2. Finding yc. For finding yc, what we need to consider? Auxiliary equation. Consider auxiliary equation. What is auxiliary equation? F of m equals to 0. What is f of m? What is f of m? In our function f of theta, in place of theta, we have to take m. So in equation number 1, now we are finding a solution for equation number 2. Forget about equation number 1. Okay, so concentrate only on equation number 2. How to get solution of equation 1 is that we'll discuss. Okay, so what is f of m equals to 0? We'll get m square minus 2m plus 1 is equals to 0. Then if we find the roots for this, it can be written as m minus 1 whole square equals to 0. Then m is equals to plus 1 and plus 1. So two roots are existing, two roots are real roots, and that roots are repeated. Then what is yc? Therefore, yc is equals to c1 into e power m1x. Earlier it is m1x, but here it is m1z plus c2 e power m2x, m2z. But here the root is repeated. M values are repeated. So what is the thing we are going to get? C1 plus C2x. But in place of x, what we have to take here? Z into e power m into z. What is m value? 1. So e power z. Be careful, students. This is, while writing this, you must use z, not x. And next step is finding yp. Finding yp. While finding yp, what we have to do is, what is our actual process? Yp is equals to 1 by f of d of, not d here, f of theta of q of z. Trend changed. F of d of q of x, but in place of d we are having theta, in place of z we are having, x we are having z. So what is our f of p? Yp is equals to 1 by f of theta is theta square minus 2 theta plus 1. That is f of theta of what is q of z? In our equation number 2, what is q of z? This is f of theta and this is z. So we are going to take q of z. What is the q of z value is? Z of z. Now if we observe, how we can write this one as 1 plus theta square minus 2 theta, already constant term is 1 only. Okay, so no need to take anything common. And I am taking this one to numerator, whole power minus 1 of z. Now, how it looks like 1 plus x whole power minus 1 formula. What is 1 plus x whole power minus 1 formula? 1 minus x theta square minus 2 theta plus x square. We have to go for the next term or not? For that, we need to identify in the rough work what is the d of q of z. Nothing but here d we should not take theta. Theta of z. What is the theta of z value? 1. Why? Is it clear how you are going to get this equals to d by dz of z? What is the d by dz of z? Is 1. What is the theta square of z? 0. Theta cube is also 0. Okay, so because of this reason, we have to stop. The derivative is existing only up to whole power 1 only. So because of that reason, we have to take only up to 1 minus x power 1 only of z. Now, separating each and every, multiplying each and every term with z, what we'll get? First term is z minus of theta square of z is 0. Minus of minus is plus 2 into theta of z is 1. Plus rest all the terms become zeros. Because of already we discussed why you are going to get zeros. Please make sure that the first term is 1. 1 also should multiply with z. Yp is equals to z plus 2 is yp. Okay, taking this as equation number 5. Now where we have to substitute 4 and 5 in equation number 3. Substitute equations 4 and 5 in equation what? 3. That implies y equals to yc plus yp. That implies y is equals to, what is yc we got? c1 plus c2z into e power z plus yp is z plus 2. This is the general solution of equation number 2 only. Is general solution of equation 2. But after getting the general solution of equation number 2, how to find the solution of equation number 1? What we discussed, what we substituted, put x is equals to e power z. That are the things we have to replace. Replace x is equals to e power z and z is equals to log x. These things only? Yes or no? So we have to replace these things. Then what we are going to get, where we have to replace? In the recent equation. Okay, so that reason only I am not taking any equation number for the previous equation. Y is equals to c1 plus c2 into, what is z value? Log x. Into, what is e power z value? Is x. Plus 2 into z. Z is nothing but log x. This is the general solution of given differential equation number 1. Is general solution of given DE. This is the case. Now, how to identify? We have to apply this method only. That you can observe by seeing the problem. What is that? What is the point I discussed? Wherever d is there, that coefficient should have x power 1. Wherever d square is there, that coefficient should have x square. There may be a constant also, may be there. For example, if we have d cube somewhere, if we have d cube, what is the d cube coefficient? Constant should be What is the d cube must and should be? Some constant value into x cube. So it should be there. This is one point. And the other point is, do we got log x right hand side anywhere till now? No, we did not get. So even if we are getting like this, then we have to solve our problem using Euler-Cauchy's linear differential equation. But check here in the given problem, is it they mentioned we have to use the Euler-Cauchy's method or method of variation of parameters or any other cases? No. So like this, we have to identify. This is our problem. This is our problem. Now, if we observe, is there any chance of right hand side 65 into cos of x? Do we got any problem like this till now? No, no. But we are getting the right hand side in terms of log x, so that it is clear that we must use what is the case? Euler-Cauchy's method. But writing the given differential equation first. Given differential equation is x cube. I am writing it in the form of operator form. X cube d cube plus 3x square d square plus x dy. I am writing only xt plus 8 of y is equals to, what is the right hand side part? Will be the same, 65 into cos of log x form. So we can say that equation 1 is a Euler-Cauchy's linear DE. Because right hand side we are having log x, and same manner wherever we are having d, the coefficient is x power 1, d square is there, x power 2, d cube is there, x cube, like this, because of that reason. Now immediately what we have to substitute? We have to go for substitution. So what we have to substitute here? X equals to e power z. Same substitution, no change. Put or consider x equals to e power z. That implies z is equals to log x. And other than these things, what are the things we need to substitute? Xd equals to theta. We are having x square d square also. What is x square d square value? Theta into theta minus 1, which is equals to theta square minus theta. And we are having x cube d cube also, the term x cube d cube also. So we need to take x cube d cube also. What is x cube d cube? Theta into theta minus 1 into theta minus 2. Then if we do the simplification, theta into, what is the theta minus 1 into theta minus 2? That can be written as theta square minus 3 theta plus 2. If you do the simplification, you will get this. Then what is x cube into d cube finally? Multiply all the terms with theta, we'll get theta cube minus 3 theta square plus 2. This is our x cube d cube. What is x and what is d? Oh, sorry, what is d and what is theta here? D is a d by dx, theta is a d by dz, where these are the things you must write. D equals to d by dx and theta equals to d by dz. And we must put them in the box also, sorry, d by dz. Now we have to substitute all these things in equation number 1. Yes or no? So substitute all these things in by substituting all these things in equation 1. In equation 1, then equation 1 reduces to, what is x square d square? Theta cube, sorry, x cube d cube, theta cube minus 3 theta square plus 2 plus 3 into x square d square. What is x square d square value? Theta square minus theta, or everything we kept it in the box, plus x into d is nothing but theta, plus 8 of y is equals to 65 cos of what is the log x value? Z. So doing some more simplification. Is it clear, everybody? If you are getting any doubt, immediately you unmute and ask. Then writing directly the highest powers of theta. What is the highest power of theta? Theta cube. So what is the thing we are going to get? First term will be theta cube. Is there anywhere we are having the theta terms? Sorry, theta square terms? Yes. Minus 3 theta square plus 3 into theta square. So plus 3 theta square. On simplification, we are not going to get any theta square term. Okay. So no theta square term. Minus what is the theta terms? Plus 3 into minus theta is minus 3 theta plus theta. Minus 3 theta plus theta becomes as minus 2 theta. Okay. Next term, theta cube terms completed, theta square terms completed, theta terms completed. What is the remaining constant term? What are the constant terms? 2 is constant, 8 is constant. Plus 2 plus 8 becomes as 10. Plus 10 of y is equals to 65 cos z. 65 cos z. Taking this as equation number 2. Now what is equation number 2 is a linear DE with constant coefficients. So is a linear DE with the constant coefficients. But our equation 1 is a with the variable coefficients. That is, it is in the form of f of theta of y is equals to q of z form. Now, what is its general solution? Then, general solution of equation 2 is you people sit and listen the class. Okay, what is the general solution? Y equals to yc plus yp. But where yc and yp are in functions of which variables? Z variables. We are going to find in terms of z. Okay, so now going to take our case yc. Finding yc. How to find yc? Consider auxiliary equation. F of m is equals to 0. Our f of theta is theta cube minus 2 theta plus 10. So all of you please take the calculators. Theta cube minus 2m, sorry, m cube minus 2m plus 10 is equals to 0. Now we need to find the values of m. So in your calculators, use synthetic division or use your calculators, then find out the values. In our calculator, we have to take equation and it is a cubic equation. So m cube coefficient is 1 and m square coefficient is minus 2. Sorry, m square coefficient is 0, not minus 2. M coefficient is minus 2 and the constant term is 10. Then if we find, then we are going to get is there any mistake we made?
Sir, minus 2.46 some.
Yes, wait. I think we made some mistake. Let me check. Oh. Plus theta. I think somewhere problem is wrong. Let's just wait a minute. Students, we made a mistake here. What we did, at the time of finding x cube d cube, here at the time of finding x cube d cube, we got like this. We have to multiply each and every term with theta. If we multiply each and every term with theta, what we'll get? Theta cube minus 3 theta square plus 2 theta. But I forgot to write it. Okay, so I'm writing here, it is 2 theta also. Then what we'll get here? Here we'll get 2 theta. Then if we do the simplification, sorry, we'll get 2 theta, but 2 theta plus theta is 3 theta. 3 theta minus 3 theta is 0. So we are not going to get anything here. So that mistake I'm correcting. This equation is going to become like this. Okay, what it's going to become as? It's going to become as theta cube plus theta square terms will not get, theta terms will not get. What about the rest? Constant term only 8 plus 8 of y is equals to 65 cos z. So rectified the mistake. And then here, what is our auxiliary equation we have to consider? The auxiliary equation what we consider is wrong because of the equation changed. So what is the auxiliary equation? Here it is m cube plus 8 is equals to 0. Now using this m cube plus 8 is equals to 0, find the roots here. So m cube coefficient is 1 and m square coefficient is 0, m coefficient is 0 and d, that is a constant term, is 8. If we find this roots, m is equals to minus 2 comma 1 plus or minus I into root 3. Is it clear? These are the roots. So one mistake is going to change our problem. How I identified our mistake? While we find the roots here, then we got that the points always m value should be real numbers or complex numbers or surds, not more than these things. Now, if we got a 2 point something or minus 2.4 something like that, so we identified. But if we are getting the general case, then if we are getting the real roots, then we are unable to identify whether we are doing the correct or not. So as anybody can do the mistake because we are human beings, but if we are doing the same mistake in the examination, then it is wrong. Okay, so if we identified and rectified the mistake, then it may be better for us. So finding yc, yc is equals to c1 into e power minus 2x. Instead of x, what we have to take? Z plus, what is a plus or minus ib? A plus or minus ib. Forget about b is root 3. So it is a complex root. Whenever it is, these are the complex roots. How we have to write it is as e power az, nothing but a value is 1, e power z into c2 cos bz, b is root 3 into z, plus c3 sine of root 3 of z. This is the thing. This is equation number 4 is the complementary solution. Now we need to find the particular solution or particular integration. For finding the yp, what is our yp formula? 1 by f of theta of q of z. Q of z. What is f of theta? Theta cube plus 8 of, what is q of z? What is the q of z? 65 cos z. Now check how it looks like, which type. It is in the form of which type of yp? Which type of yp? It is in the form of type 2. Put d square equals to how much? Minus a square. What is a value? 1 is equals to minus 1. But do we have d square? No. We are having the highest power of, sorry, here it is not d square. Please be careful. It is theta square. It should be theta square. Put d square equals to minus a square, nothing but here it is theta square equals to minus a square. So in place of, okay, we are not having theta square, but we need to find theta cube also. Multiply on both sides with theta, then we'll get theta cube equals to minus theta. These are the things we have to substitute here. If we substitute this, we are going to get yp equals to 1 by minus theta plus 8 of 65. I can write as a prefactor of cos z. Now we cannot find the problem. We cannot go with the type 2, but we must go with the type 2 only. But because of that reason, rationalize it. What is the denominator? 8 minus theta. Rationalization is nothing but what we need to do, multiply and divide with 8 plus theta by 8 plus theta. So numerator and denominator both are same, so that no change. We are going to get here into of cos z. Now what is the numerator part is going to become 65 into 8 plus theta by what is the denominator is going to become a minus b into a plus b. 8 minus theta into 8 plus theta is 8 square minus theta square of cos z. Now again using the type 2, what we have to substitute? Put theta square is equals to same minus a square, nothing but minus 1 only. Minus 1 only. Okay. So this is the thing. Now what is going to become? 65 by what is the denominator is going to become? 8 square is 64 minus of theta square value is minus 1 of 8 plus theta of cos z. Now what is the numerator and denominator gets cancelled? 65 by 64 plus 1 is 65, and multiplying both the terms with cos z, 8 cos z plus theta of cos z. What is the theta? What is the theta? If you are not writing on the top, wherever we substituted theta is equals to d by dz, then you are going to keep like theta only. Here it is. So cos z plus, okay, I am writing theta of cos z in the rough work. Theta is nothing but d by dz. D by dz of cos z is minus sin z. So with this, we are going to get here 8 cos z minus sin z. This is our what? Equation our yp. Equation number 5. What is our next process? Substitute. We got yc and yp. Equations 4 and 5 in equation 3. What is equation 3? Y equals to yc plus yp. Here we have to substitute. That implies y is equals to yc. Yc is c1 into e power minus 2z plus e power z into c2 cos of root 3z plus c3 into sine of root 3z, root 3 into z. This is only yc plus what is yp? 8 cos z minus sin z is general solution of equation number 2 only. This is the general solution of equation number 2. How to find the general solution of equation number 1? Replace what is x equals to e power z, and what is that? Z is equals to log x. These are the things we have to replace. Now here what I am doing is I am taking e power minus 2z is there. Okay, better I'll write one more step, our previous equation like this: c1 into e power z whole power minus 2. Is it okay? I am writing e power minus 2z as e power z whole power minus 2 plus e power z into c2 cos of root 3 of into z plus c3 sine of root 3 of z plus 8 cos z minus sine z. Okay, this is the thing. Now replace z with log x and also e power z with x. Then what is going to become? Y is equals to c1. What is there? E power z is nothing but x. X power minus 2. X power minus 2 is nothing but what we can write? Can I write it as 1 by x square? I hope you people can understand. 1 by x square plus e power z is nothing but x into c1 cos of root 3 into, what is the z value? Log x plus c3 into, here it is c2, sorry, c3 into sine of, what is that inside the brackets? We'll get root 3 into z. Z is nothing but log x plus 8 into cos of z. Z is nothing but log x minus sine z. Sine of z is nothing but log x. That we will substitute. So this is a small solution. Not small. I am giving in the reverse direction. Means it's a big solution, but shall we find the solution, this solution using our previous procedures? No. Is general solution of given differential equation. Clear? This is a process. So this is the problem, given problem. How it is in the form of okay, writing as it is, the given differential equation is like this. Okay, given DE, solution of the problem, given DE is, what is this differential equation? D square coefficient is x square. D coefficient is x, nothing but is a Euler Cauchy's linear DE. Or Cauchy's homogeneous linear DE also we can call it is Euler Cauchy's linear DE. With the variable coefficients. With variable coefficients. So what we have to substitute here, as we discussed earlier, put x equals to e power z, and same manner that implies z equals to log x. These two things we have to substitute, as well as what we have to substitute, xd equals to theta, x square d square is theta into theta minus 1. Theta into theta minus 1 is nothing but, sorry, theta into theta minus 1 is nothing but what we can say with this, theta square minus theta. So x square d square equals to theta square minus theta. These are the things we have to substitute. Now, where we have to substitute? Okay, what is the d here? Where d equals to d by dx and theta is equals to d by dz. D by dz. Now, substitute all these things in equation number 1. In equation 1, then it's going to become, what is equation number 1? X square d square minus xd plus 2. Okay, I am remembering this. X square d square is nothing but theta square minus theta minus xd. Xd is nothing but theta plus 2 of y is equals to, right hand side is x into log x. What is x? E power z. What is log x? Is z. So once again checking, x square d square minus xd plus 2 of y is equals to x log x. Now simplifying this one, we are going to get theta square minus 2 theta plus 2 of y is equals to z into e power z. I am writing like this. What I discussed in the previous cases, whenever x into e power x or e power x into x is there, then try to use type 5 that I mentioned. Equation 2 is a linear DE with the constant coefficients. With constant coefficients. Okay, now how to do this simplification? This is in the form of f of theta of y is equals to q of z. F of theta of y is equals to q of x. What is the q of x here? It is q of z form. So what is the general solution? Y equals to yc plus yp. Find the complementary solution. Will be in terms of z variables. Going to get in terms of z variables, and also yp. Yp also should be in terms of z variables. Then after finding the things, we have to replace z is equals to what we substituted here. Z is equals to log x. Same manner, e power z equals to x. Then we are going to get the general solution of the equation number 1. This is the actual process. Now we need to find the what is the general solution is. Then general solution of equation 2 is y equals to yc plus yp. Why I'm writing each and every step is, you should not get any confusion while you refer the PDF or while you watch the video. Okay, so that reason I'm writing each and every step clearly. Okay, so now finding yc. For finding yc, we need to consider auxiliary equation. Consider auxiliary equation. F of m equals to 0. F of theta. From f of theta, we have to get f of m. M square minus 2m plus 2 equals to 0. Then we need to find the values of m. So I'm using calculator for making our problem is simple. So in our calculators, we have to go for equations, and it is a quadratic equation only. So a coefficient, x square m square coefficient is 1, and m coefficient is minus 2, and the constant term is 2. Then we are going to get the roots are m is equals to 1 plus or minus I. So I'm doing using calculator directly, but you can write like this, but you mention in brackets using calculator. Okay, so therefore yc is equals to e power ax. It is in the form of a plus or minus ib. So a is 1. So e power az into c1 cos bz, b value is also 1, plus c2 sin bz, b value is also 1. So getting equation number 4. Now we have to go for next step, yp. Finding yp. What is the yp process? 1 by f of theta of q of z. So now you can understand why I am writing in each and every problem this way. Like in the previous cases, I have written yp is equals to 1 by f of d of q of x. Why I have written there? Because of this case. Here you are getting not d and x. We are getting theta and z. So denominator will be theta square minus 2 theta plus 2 of q of z. What is the q of z? Here it is z into e power z. Z into e power z. Okay, z into e power z. Now, if we observe, it looks like which type? X into e power ax form. So we can apply type 5, or you can apply type 4. Anything you can apply, but it is better to apply type 5 instead of type 4. Okay, so what is a type 5? 1 by f of d of or f of theta of z into v of z is there. Then the process is z into 1 by f of d of theta square minus 2 theta plus 2 of v of z. V of z is here e power z minus f dash of d. What is that? F dash of d? F dash of theta, nothing but. Okay, so 2 theta minus 2 by denominator is theta square minus 2 theta plus 2 whole square of v of z is e power z. So better I am writing the formula here using type 5 of finding yp. Type 5 of yp. What is the formula? 1 by f of theta of x in z into v of z. I am writing in terms of z only, just not to get any confusion, is equals to. So we get is equals to, what is the formula? Z into 1 by f of theta of v of z minus f dash of theta by f of theta whole square of v of z. This is a process. So using this formula, I expanded here the formula. Now, same manner, that implies yp equals to, better I am using a different color. Okay, z into, what we have to substitute here? What we have to substitute here? Put, it is in the form of type 1. Put d is equals to 1. Is it, do we got d is equals to 1 is a root? No. And same manner, sorry, not d it is theta, because now we are in a different mode in terms of thetas. Here also we have to substitute theta is equals to 1. What I mentioned earlier, we are substituting in place of theta that a value using type 1. It may be in denominator as well as in numerator. Numerator also we can substitute, no problem at all. Further, I give an explanation also. So 1 square minus 2 plus 2 of e power z minus of 2 minus 2 by 2 into theta is 1. So 2 minus 2 is the numerator part by 2 square minus 2 plus 2 whole square of e power z. So what we are going to get finally? Z by 1 into e power z. This is our yp. But because what about the next term? 2 minus 2 becomes zeros. 2 minus 2 numerator part becomes 0. That implies yp is equals to z into e power z. This is equation number 5. After getting the yp, we need to substitute equations 4 and 5 in equation 2. Sorry, 3. That implies y equals to yc plus yp. So we got y is equals to yc. Yc is e power z into c1 cos z plus c2 sin z plus yp. Yp is z into e power z. So this is the general solution of given general solution of equation 2. Equation 2. But we need to find the general solution of given dA. So that replace z equals to replace e power z equals to x and z equals to log x. If we replace these other things in the recent latest solution, then we are going to get, that implies y is equals to e power z is nothing but x into c1 cos of z, z is nothing but log x, plus C2 into sine of z, z is nothing but log x, plus z into, z is nothing but log x into x, e power z. E power z is nothing but x. That x I am not writing as a post factor, I am writing as a prefactor. So E is the general solution of given differential equation. Is general solution of given DE. This is the solution. So we are not having any z variables. If we observe the right hand side part, for example, the fourth problem, just I will explain briefly how to do our process. If we observe the right hand side part, how it can be written as a plus b whole square formula, a square plus b square plus 2ab is 2x. But in place of x, we are substituting z. So it will become as 1 plus e power z whole square is nothing but e power 2z plus 2 into e power z. So it when the fourth problem is in the form of left hand side d power 1 x power 1 d square x square. So d square coefficient is x square, like that. It is a Euler linear Euler Cauchy's linear differential equations with variable coefficients. But here if we substitute x equals to e power z, z is equals to log x, like that, then the right hand side part will converge like this, and substituting x, d is equals to theta x square, d square equals to theta square, theta into theta minus 1 like that in the left hand side part, then it converts to f of theta of y is equals to right hand side part is q of z. The q of z is like this. Then it is in the form of the first term is in the form of 1 can be written as e power 0 type 1. Second term is also type 1 e power az e power sorry, here it is z, not x, e power, wait, e power 2z plus 2 into e power z, e power az plus 2 into e power a value is 1. So here theta is equals to, we have to substitute 0 in this term, theta equals to 2 in this term, we have to substitute theta is equals to 1, like that. Using type 1 we have to continue. Okay, so same manner, what is this fifth problem? If we apply the same manner, the right hand side part, 10 into e power x is nothing but x is nothing but e power z plus 1 by x is nothing but e power z, 1 by e power z is nothing but e power minus z. Then we have to apply type 1 and type 1 for finding yt. This is a process. But when it comes to the sixth problem, so I'm going to explain solve this sixth problem. Here, if do we have d square coefficient is x square? No. D coefficient is x power 1? No. So because of that reason, I'm explaining this problem. Solution of the sixth one is, given DE is d square plus 1 by x d of y is equals to 12 log of log x by x square. Okay, anyhow, before I'm going to take these other things like this, here on both sides, what I'm doing is multiplying with the x square. Okay, so multiplying with x square, so it will become I am writing here, given differential equation can be written as multiplying with x square, then we'll get x square d square y by dx square plus x square by x into dy by dx is equals to 12 log x. X square by x square gets cancelled. So if we write it in the form of differential operator form, we'll get it is as x square d square plus x d of y is equals to 12 log x. Now, as we discussed earlier, it is in the form of Euler Cauchy's linear differential equation with variable coefficients. Is in Euler Cauchy's linear differential equation with the variable coefficients. With the variable coefficients. So first of all, we have to convert this one into a linear differential equation with constant coefficients. For converting it into linear differential equation with constant coefficients, using our procedure, we have to substitute here x equals to e power z. That implies z is equals to log x. And we have to substitute here xd equals to theta, x square t square equals to theta into theta minus 1. X cube d cube is here they given only x square d square, so I'm writing only these things. Where what is our d? D by dx, and theta is equals to t by d square. This is important for our future steps. And this x square d square can be written as theta square minus theta, which is x square d square. Okay, if we substitute all these things in equation number 1, by substituting in equation number 1, it reduces to, by substituting in equation 1, then it reduces to as follows: x square d square plus xd. So x square d square is theta square minus theta plus xd. xd is nothing but theta plus theta of y is equals to, right hand side part is, what's the right hand side part? 12 into log x. Log x is nothing but simply z, 12z. Okay, so if we do the simplification, we'll get theta square y is equals to 12z. Taking this as equation number 2. Equation number 2 is a linear DE with constant coefficients. With constant coefficients. Okay, this is the thing. Now, what is its general solution? Then, general solution of equation 2 is y equals to yc plus yp. But here, yc and yp should be in functions of z variables. Because of our second equation is in terms of y and z. So this equation is in terms of, that is, it is in the form of f of t of, okay, better I'll write like this. That is, f of theta of y is equals to q of z. So these are our equation number 1. In equation number 3, in equation number 3, yc and yp will be in functions of z variables. Now we need to find yc. For that, we need to consider auxiliary equation. Consider auxiliary equation f of m equals to 0. Our f of theta is theta square only. So f of m is m square equals to 0. That implies m is equals to 0, comma 0. So two real roots are existing. The two real roots are zeros and are repeated. Okay. So yc is equals to c1 plus c2x into, but in place of x we have to get z, c1 plus c2z into e power 0z. On simplification we'll get c1 is equals to yc is equals to c1 plus c2z. So finally we are getting that yc is equals to c1 plus c2z into e power 0z. 0z can be written as e power 0 is nothing but 1. So finally taking it as equation number 1, c1 yc is c1 plus c2z. Yp 1 by f of theta of q of z. 1 by f of theta is theta square and q of z is 12z. So here we have to use 1 by f of theta of z power 1 is there. It is in the form of type 3. But here we are not having any constant terms in the denominator. So directly, as we discussed earlier, d is nothing but d by dx. Okay. And 1 by d, nothing but reciprocal of differentiation is nothing but integration. So in the same manner, we can take here, we know that theta is equals to d by dz. But now what we can take 1 by theta as integration of that integrating with respect to z variable. So because of this reason, here we are having 1 by theta square. 1 by theta is nothing but 1 integration. 1 by theta square is nothing but 2 times integration of 12z with respect to same dz. 2 times. So 12 into integration of 1 time integration of z is z square by 2 into dz will get. So 1 by 2 bringing outside, 12 by 2 becomes as a 6. Integration of z square into dz is z cube by 3. If we do the simplification, 2z cube is our yp. Taking this as equation number 5. Substituting equation number 4 and 5 in equation number 3. Substitute yc and yp in equation 3. That implies y equals to yc plus yp. Yc we got c1 plus c2z and yp we got 2 into z cube. This is a general solution of equation 2 only. Equation number 2. But we need to find the general solution of equation number 1 so that replace what we have taken x equals to e power z. So e power z equals to x and z equals to log x. These are the things we have to replace. If we replace in the above equation, these are the things, we are going to get y equals to c1 into c2, z is nothing but log x. Sorry, c1 plus c2. One second. C1 plus C2 into Z. Z is nothing but log x plus 2 into Z cube. Z is nothing but log x whole cube. So this is the general solution of our given differential equation. Is given Euler Cauchy's linear differential equation. Okay. So with this, I'm stopping.